You're going to need to be able, like I said, to write the formula for an ionic compound and also name that ionic compound. Let's focus on writing the formula for that ionic compound. I kind of liken it to you have a closet of cations and you have a closet of anions, and it's wonderful. You can actually mix and match any cation with any anion in general. So I really like this. It's called the crisscross method, and I think Tro does this also, where basically it goes like this. We need to, well, let's start out like this. What if I have a cation A, and I'll make it a +2, and an anion, I'll call it B, and I'll make it a -1. So I want to combine that cation with that anion, and I need to make what's called a neutral formula unit. It needs to be neutral. It needs to be no net charge. So the crisscross method says that in order to basically combine these two and make it so it's no net charge, if I go ahead and take the charge of the cation and make it the number of anions I need, and the charge of the anion and make it the number of cations I need, see the crisscross? Okay, then actually I'll make a neutral formula. So according to this approach, can you see where the number of A's I need is 1, okay? The number of B's I need is 2, okay? Notice that I made them subscripts. That's an important thing here. That's how many I need. That's like our H2O, those little subscripts say how many we have of each of them. Notice that if I do this, then actually I end up with a neutral formula unit. Let's check it out. So if I have one A and it is a +2, and if I have two B's and they are both a -1, okay, notice I'm going to add this all up, and what do I get? I get, I'll put it not divided by, I get 0, okay? So that is a neutral formula unit. Crisscross will get you there. I think that is so cool. There's one little thing I need to clean up later, but crisscross pretty darn much well works. So I want to focus, actually in lab we'll kind of do lab in 3 parts, and the first part is kind of this simple where we have, it's binary, which means what, 2, and we're dealing with only monoatomic ions, so only 2 elements kind of crisscrossing. Of course, our cation is going to be what? The metal, and then our anion is going to be the nonmetal, and we need to crisscross and make a neutral formula unit. So let's go ahead, and I'm looking at the previous slide, and I'm going to pick on, let's see, which metal. Let's go ahead and pick on magnesium. Now you should be able to go ahead and tell me the charge of magnesium. It's +2 because it's 2A. I want to combine it with phosphorus. What's the charge of phosphorus? It's -3 because it's 5A. It picks up 3 valence electrons. So let's go ahead and crisscross. So I'm going to go ahead and write the neutral formula unit. Well, how many magnesiums do I need? I need 3. I'm going to make that a subscript. How many phosphoruses do I need? I need 2. I'm going to also make that a subscript. Okay, so actually the neutral formula unit for, and we're going to talk about how to name this, but it's magnesium, and the last name is going to be phosphide, I-D-E. Magnesium phosphide is Mg3P2. So I've got some figures to kind of go along with that. So here is to make sodium fluoride. Sodium is a +1. You can kind of see that 1 valence electron is going to go. The fluorine is a 7A. You can kind of see those 7 valence electrons around. The sodium loses an electron to the fluorine. Sodium becomes a +1. Fluorine becomes a -1. And can you see where to make this neutral, all I need is 1 of each? Okay, so in other words, if I go Na plus 1, F minus 1, and I crisscross, can you see where the neutral formula is NaF? And it's a wonderful life. Well, what if instead of fluorine, what if we pick on sulfur? Sulfur is 6A. You can kind of see those 6 valence electrons around that sulfur atom. So each sodium is going to lose 1 electron, become a +1 charge. The sulfur is going to pick up 2 electrons, become a -2. And now, voila! This actually then is what sodium sulfide would look like. where the way I think of this is think of the dot, 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 those ionic bonds we talked about kind of being between that sulfide ion and the sodium cations, okay? So notice the crisscross worked just fine here too. Na is a +1, sulfur is a -2. If I crisscross, guess what? I end up with Na2S1. Now this is an example of two polyatomic ions. So we have ammonium, and we're going to talk more about this later, but ammonium is NH4 with a +1 charge. It's got 5 atoms stuck together, running around with a +1 charge. Carbonate is CO3, 2-. Okay, now if I crisscross here, notice that the number of ammoniums I need is what? 2. So that actually is one of our rules. If we need 2 of these, then we better put NH4 in parentheses and outside put the number 2. And then how many CO3s do we need? We just need 1. Okay, so there's no need for parentheses if you only need 1. So to kind of show you, well, I guess I don't show you the structure, but so ammonium, NH4+, and yes, you will have to commit that to memory, and I'll kind of give you some hints on which ones you need to know. That's a polyatomic ion. Carbonate is CO3, 2-. So crisscross, and there you go. Now sometimes I tell students, and I'll kind of remind you this in lab, if you are more comfortable putting that carbonate in parentheses and putting a 1 outside, I sure couldn't fault you for that. So the pattern we've been seeing is you always put, ladies first, no, you always put the cation first and the anion second when you write the formula. And actually when we come up with names, it's going to be, you're going to name the cation and then you're going to name the anion. Let's see, charge of individual ion is not shown. Oh yeah, this is an important one. Do not show the charges. Do not show the pluses or minuses in your final formula. What else we got? The example we saw with the ammonium carbonate a minute ago, actually when we needed more than 1 ammonium, we had to put it in parentheses. NH3, 2. Okay, that's all that is talking about. Okay, oops, magnesium chloride. I did have this example in here. So magnesium, hopefully you would tell me, is a +2 cation. Chlorine is a -1 anion. If we crisscross, can you see where we need 2 chloride ions, and we need only 1 magnesium? Okay, so now I've got some here to kind of give you some practice at, I think, kind of writing what we call the neutral formula, writing the neutral formula unit. And crisscrossing works here. So the formula for potassium chloride would be KCl, sorry. The formula for aluminum sulfide would be, we need 2 aluminums and 3 sulfurs. So I got Al2S3. The next one. Now these what I'm showing over here in red are called the component ions. So the component ions, to me, you write that first and then you know how to crisscross. So this happens to be taking what we call the iron 3 or the iron +3, combine it with the bromide ion. Of course, that's always a -1, and when you crisscross, what do you get? Yep, you get FeBr3. How about Ag stands for what element? Ag stands for silver. We're going to combine it with oxygen, which is always a -2. We're going to see that silver is always a +1 also. When you crisscross, you get Ag2O. So kind of fun. All right. How about this one? Ammonium we said is NH4 plus, and fluorine forms a -1 charge like that. When you crisscross, what do you get? Well, you just need one of each. So it's NH4F. For this one, sorry, NH4F. So what about this one? Now, we haven't talked about this SO3 2-, but actually here in the next part, or later on in lab, or actually later on in this lecture, we're going to call that the sulfite. Not sulfate, but sulfite. So if we crisscross, can you see that we're going to need what? 2 Cu's, and we're going to need 2 SO3s. Now this is an example of if you need the same number of both of them, actually you can reduce that into just needing one of each. So I don't know if you buy this, but crisscrossing gives you two Cu's and 2 SO3s, but we can reduce that to just needing one and one. One way to look at it is if we have one of each. Do you see where that's a neutral formula unit? Where if I have 1 times +2 plus 1 of these times -2, okay, that's equal to 0. Okay. So lithium sulfate now, and again, this is part of your problem, not mine, but I told you this is sulfite. Guess what? This is sulfate, not my problem. Well, it's both our problems, okay? So they're slightly different. The sulfate actually has more oxygen. I usually tell students like I ate more oxygen, ho 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 ho, so sulfate. Anyway, so when we crisscross, can you see where, how many lithiums do we need? 2. How many sulfates do we need? 1. So the neutral formula unit looks like this. Li2SO4. The name is lithium sulfate. And then last but not least, we have magnesium, which is one of those where you can hang your hat on. I'm counting on you being able to look at the periodic table and know that it's a +2 because it's 2A. This right here is hydrogen carbonate. And again, we'll kind of talk about that later. Oops, sorry. Oh, goodness. Carbonate. All right. So when we crisscross, can you see how many magnesiums do we need? Just 1. There's a 1 up here. How many hydrogen sulfates do we need? 2. So we better put HCO3 in parentheses, and we definitely do. So it looks like this. Magnesium, oops, sorry. Magnesium, okay, and then the hydrogen sulfate is in parentheses because we need 2 of them. All right.